So I wanted to talk about the stream trait, which is close to being proposed. And I was especially interested from the Lang team's point of view that we talk about some of the things that the design commits us to or future things that we might encounter and what it means for that. So Nell and I sat down and made a little list, but maybe other people have other things to add. I guess this is wrong, I just realized. I don't know, Nell, do you want me to walk through it or do you want to walk through it?
Go ahead and walk through it.
Okay. So I might as well add this in here because it's relevant. Something like this. Yeah, you can read the actual draft here, but the core point is to add this trait into the standard library for defining streams with the goal of letting people write interoperable streams. And it's the async version of iterator. So instead of where iterator has a next method, ignore this next method for a second, I'll talk about it in a second. The next method from iterator becomes poll next, right? And it has this is not poll. Typo. It has a pinned receiver, takes in some context. So much like a future, I guess Taylor or both could also present this, but anyway, let me try it and see if you guys can correct me where I go wrong. But you have a pinned receiver in a context. And the idea is you ask the stream, is the next item ready? And either there is an item and you get it, or they get the end of stream, or you get back not yet and you have to wait. And the RFC proposes not a very minimal sort of interface. It basically consists of this one method plus one helper method. I thought we should include called next. And the idea is that this next helper method basically returns a future that you can await. So that means when you're using a stream, you can write, you can say stream.next.await. It's debatable if we want to include that, but it does seem like pretty much everybody's going to want to do that. So it would be useful to allow them to do so. There could be other helper methods you could also consider including, but there's some reasons. Somebody's typing in this loud.
I was about to ask. Yeah, it's a little hard to hear, Nico.
Not sure who's typing, but I'll mute people.
I'm typing but muted, so.
And I'm not muted, but also not typing.
Well, I'm going to mute everyone, but you can unmute yourselves. So, right, the idea was this is the minimal helper method. There could be more. There are reasons not to include all of them because things like closures and so forth, there are basically language features that get intersected, especially async closures, that affect a lot of the helpers and made me probably want to hold off on adding them. But stop here and say, does anyone have any questions on that so far? But that brings us to some of the considerations that we'll get to next.
One question so far. The next method seems like it will be particularly helpful for writing a convenient while let loop, but is there a plan and more importantly a concrete architecture for integrating this into some kind of 4xn?
In the RFC, we do address that as a future thing that we would like to do. Not as a future is an overloaded term in this RFC.
I understand.
As something we'd like to do in the future, but it's not explicitly. This RFC doesn't advocate for implementing it just yet.
Okay.
Has there been any movement on this topic since Boats' original blog post series on the whole 408 business?
No.
Okay, it might be worth linking to that because I thought that was sort of like a conclusive, like we're at least probably not going to do this direction, but maybe I'm out of date.
Well, I'm not sure if I was right now. I think that there might have been I remember there seeing an issue later and not remember, but I don't remember what it is now.
Cool.
So I think
It was definitely I think it's still worth it for context, even like Boats, maybe you might want to read through those posts and decide if there's anything you'd like to change now in terms of making a new post. But I remember thinking that whether or not the conclusion was correct, the analysis of options was really helpful in terms of talking about the implications to the language.
Yeah, but I think that what I concluded later was we will need some special syntax for processing stream instead of iterators.
Right. I think so part of the reason I bring this up now is I don't think we need to gate on having a concrete syntax for this. I do think there's value in confirming, at least with a straw architecture of some kind, that we feel like the methods that we're writing are enough to support something like that. I suspect the answer is fairly obviously yes, that obviously if we can write for while let sum equals something dot await, then we can have a sugar for that. But I think there's value in confirming that whatever magical sugar we might end up with, here's what it could translate to, and we feel like this could be language integrated, and we're not opposed to doing that.
It seems like there would be, I don't see a problem with the sugar, except there's one like tweak about next, which is that it requires that the stream be the self type be unpin, and
yeah,
that means that if you, maybe we'll talk about a bit with generators, but like if you just drop in like if we had an async generator function and we just dropped it in there, there might be an explicit pinning step required to really use next, or there would be, I guess.
Yeah, I would be surprised by that. I would expect that if we did, I mean, we can table this as I think like nobody's proposing we do this right now, but I would expect that we'd have like an into stream along the same lines of into today.
Yes, exactly.
Ownership of the object and then pin it for you.
Or whatever else needs to happen, yes.
But like a for loop syntax would just like inherently pin it, right? Because it takes ownership, so it doesn't move it as part of.
Right. Any sort of for loop syntax or any semantics that would like take ownership of the stream, this would be a non-issue, right?
Yeah, exactly. Right. So I think that's why we ultimately probably want to add for await syntax someday, because then it just solves the pinning problem for, at least for that aspect, for calling that way of calling next, right?
Agreed.
Yeah, and I know you know that I have like vague opinions about like that way of calling next, but it
yeah, right. That was the thing about concurrently and so on. Yeah, now I remember that. Yeah, but it's also something that we could consider as part of the design process if we add a special syntax. Like we could choose to.
Yeah, absolutely.
I think in particular, just to make sure we're all on the same page, Taylor, your opinion was that it's pretty rare that you just want to call next sequentially and you'd rather process items in parallel a lot of the time?
It's not necessarily rare, but I think it should be a very conscious decision. Like, I think that much more frequently, you actually want to be processing stream elements concurrently. But obviously, I think that's something that requires like taking a look at the ways people are using stream in the wild today and like what patterns we want to encourage. I think adding built-in syntax for a pattern that we might want to discourage would be bad. So we should decide whether that's a pattern we want to push people away from or not.
Right.
Well, I mean, go ahead, Buzz.
I just want to add that just like the concurrently, like for each concurrently, the problem is that we cannot make it, you can't early return inside of that, right?
Not naively, yeah.
Yeah, so we cannot make it like this desugars to something that runs concurrently, because then early return would not work inside of it. So we have to, so like if we add syntax, it has to be sequentially. And the problem is that maybe we don't want to encourage sequential. Yeah.
I mean,
well, like I'm like maybe jumping ahead here, but like you could imagine something that did like some kind of trampolining step, right? It's similar to how we use the like try methods on iterators today, and then it could automatically propagate, returns and tries or something. But like, we may or may not want that. It could be cool.
Yeah.
I think let's cut this off a little bit and come back to it. But it does seem like the other kind of, these are all specific problems to the syntax. It also is true, right, that we might not commit early returns from inside of such a for loop. Like we can put limits on what you can do inside the loop also, but that's kind of, I feel like we can discuss that when we discuss, like it doesn't affect the stream trait itself, the design.
Yeah,
of the stream.
plus one to that.
So one of the things I thought of that I wanted to talk about, one of the very simple ones is when we add a minimal trait like this, we have a bunch of helper methods in the futures crate, but we probably will want to eventually move them over to the main trait, or at least some of them, similar to how we sometimes want to migrate things from iter-tools to iterator and stuff like that. And we have no good way to manage that right now. Like that creates ambiguities, which then cause existing crates to fail to compile, which is not great.
I felt like, wasn't there a discussion at some point about adding some sort of attribute that we could use to say like, prefer this one? I don't remember. I mean, it's obviously messy, but I don't remember where that conversation went.
Yeah, that's right. I'm bringing this up in part just to highlight it as this may be work that we wind up needing to do. Like it's kind of work we already kind of have to do, and this priority of it may increase because of adding the stream trait.
Wasn't there a discussion at some point, or several discussions, about the notion of how would we have done iterator and its myriad helpers differently if we did them today? Because I wonder if we did it today, if we would add 50 methods to trait iterator, or if it would make more sense to have them attached on the side somehow where they weren't necessarily methods of the trait.
I would definitely not change how it is, but it seems like sort of a lib's concern.
Yeah, it also seems like it has a lot of interaction with specialization, or like what the alternative is, right?
Right, yes, that's what I was getting at.
Yeah, I think
Like,
right now
in
the
theory,
only
if we
other,
had... Go on, Scott.
I think the only other option we have right now would be to have a new extension trait for every method that we add that I don't think is superior. So we'd need some new language feature.
Right. And presumably we would need specialization to be able to say, you get a default impl that is a blanket impl for iterator. Some methods might only be for iterator plus some additional qualifications. And then you might have specialization for cases where you want to override a given iterator method because you can do it more efficiently.
I guess we could consider, if we like decided that we don't want certain methods to be overridable, that they always just delegate to the internal thing because they're always just as fast that way, but it seems unlikely. We did just have people proposing moving yet another iter-tools method over to iterator, and called out we have no good way to disambiguate this when the ambiguity happens. So that's making me want that feature again over there as well.
Wouldn't feature detection also work here? Say the extension trait that futures OS provides doesn't implement a particular method if it's on a particular Rust version. So then through Semver, if people like just upgrade.
Oh, I see what you're saying. Effectively, if iter-tools or similar used like config available to say, if this method exists in Rust, then don't add it.
Yes.
Yeah, I think. Go on, Buds.
The problem that would be, it would still break people who have a lock file. Like as soon as they upgrade to that version, they would not, because we would add a new version of Futures Crate that contains that CFG as soon as we knew there was a version that this was going to be added in. But people who have a lock file that doesn't specify that new version would still be broken by the upgrade. Because people don't automatically get updates.
What's our like concrete policy around breakage for those kinds of things?
Yeah,
like,
technically I think they're allowed. Like, but
right.
Yeah.
Also,
and
we don't have to wait and do them in lockstep. Like config available could be added now, even if the other changes to Rust core would not happen for a year, and at that point there'd be a lot less detected breakage.
Right, I forgot that it's available and not a version, because like if we need to know the version number, then we can't do it until we know what we're
right, which is exactly why config available works better for this.
Yeah, definitely.
I also point out that the ambiguity won't actually exist until the stream trait in futures core forwards to the one in like upstream SCD, right? Because by default they wouldn't be the same trait.
But we were going to do that if it's stable, right?
Right, and at that same time, so that anybody who had that update would also have the update to remove whatever these methods are that are overlapping.
Well, the issue is that we're not. I think the RFC currently doesn't add any methods.
Currently at next, I thought, but
well, yeah, but it doesn't add map or any of these. And so, like, when we do want to add them, because presumably we want to have stream be roughly as featureful as iterator, then it's going to be breaking people who currently use the ones in futures.
Yeah, that makes sense. Thanks for clarifying.
Yeah. I think accessible seems like actually a really good fix for this problem.
It's certainly a lo-fi fix, so to speak.
Yeah.
And maybe it's good if we can only do it, or like maybe it's okay that it's only, it requires careful coordination to work. And that means we won't do it willy-nilly, but we shouldn't do this. We should be careful.
Yeah. No, the big issue will be that it will break. If the signature is not exactly the same, then it won't work. So that's sort of the...
Yeah, I was wondering about that. If we ever make tweaks as we add things to the standard library, then, but maybe the answer is, well, I don't know. Yeah, the only other alternative I can think of is some kind of priority annotation, which is kind of a, could work, but it's also one of those features where you, I don't know, when you have two priority things, then which one wins?
Well, and in the case of, if you're trying to prevent breakage due to like a change in the function signature, you would actually want the one in the futures crate to have priority over the one in STD, which is all kinds of backwards.
Yeah, I think that's what you would mark the standard library as sort of low priority, so that you get the code you had before, but that's, as you say, that's good for existing crates, but maybe not what newer crates want.
Right, newer crates might want to know that they won't be subject to random monkey patching.
Yeah, I wish we had a way to disambiguate method names off traits that's not quite as far as a jump as going all the way to UFCS. That was discussed as like paths in method names before or something like that. I don't know if that's necessarily the best way, because that opened up the whole, well, can you just call functions with method syntax conversation? But having some way to do this that doesn't require it be function syntax instead of method syntax and doesn't lose deref and all that sort of stuff would be nice.
I wonder, all right, I think we should move to the next topic, but I do want to, I'll just say one last thing and then people can have one last round of comments and then we'll move, but is that it may also be something that winds up getting tied to additions. I could imagine it. So that would be a possible turning point where you can like introduce new things and migrate people over when they move the addition. I don't know.
It keeps getting talked about for libs, but it's a little more complicated, I think, for doing it for method resolution on traits than normal addition things.
Yeah, I don't quite know how it would work.
Oh, I was just assuming that the method would just only exist in the new edition or something like that.
That's what I had in mind.
I thought we couldn't do that because mixing stuff still needs to be able to use it.
Part of the RFC is replacing the trait in the futures crate with a reference to the trait in the standard library.
Right.
Yes.
But the question is, we could say that you can add members like methods into a trait that do not participate in .dispatch or only participate in .dispatch based on the addition of the crate that is calling them. And then that would allow us to move methods later from futures crate into standard library, but over some addition boundary such that like old code gets rewritten to UFCS, I guess. I don't know. We'd have to work it out. It's kind of complicated. And messy, but might be practical.
I think it's possible that the best solution to this would just be to like only do this once and just accept that, like have a release ready, prepare everything to try to encourage like basically do a flag day, but only do it once around these methods, rather than trying to make it never break anyone.
Yeah, so kind of not solve it, but just
Yeah.
it. Yeah.
So there would just be one version where this, like, because we are allowed to make this breakage, right? It's like in our stability policy. And so if we do it with a lot of communication and a lot of preparation and make it as smooth as possible, hopefully we can afford to do it once. We can't afford to keep adding new methods like every release. That I think would be untenable.
What do you think smooth as possible looks like here?
Having like, so it's the only issue is when the signatures change, but if like there's an upgraded version of futures that is exactly the same, except it doesn't contain these methods.
So your idea was that you would have to update your version of futures at the same time as your version of
this new version, yeah, which would be obviously painful, but like.
And also, it would be technically be a breaking release of futures, right?
Yeah. So it would have to be and so that we'd also want to coordinate with as much of the ecosystem as possible to prepare a release that depends on the new version and stuff.
So if we did not change the signature of the methods, and if we used something like config accessible so that either the method is available from futures or the method is available from std, but either way the method's available, wouldn't that technically make it not a breaking change?
Yeah,
such that we could make it that we're compatible?
That would be really great if we could just release a compatible version of futures.
I think that's a really good argument that we should get config accessible working sooner rather than later.
I think
or at least there's a longer on doing this. Like we don't know how soon we want to.
So
sure.
Right. One thing I will also say is this problem is not specific to Stream. We have it for Future too, right? Maybe.
Yeah, but I don't know that the futures combinators have proven to be very important.
Yeah. And certainly we have it for.
They're certainly less significant given async await syntax. Yes.
Yeah.
And
like
a lot of, I think a lot of ones that like new abilities aren't method syntax either, right? Like join and select.
Exactly. Yeah.
Sure.
At least in futures.
Which, by the way, I think that those are something we should have a conversation about getting into standard as well, but that's another day's conversation.
Yeah.
Yeah, +1.
Right. So I think these are the other examples, right? So Stream may become the most important in some sense, if only because, I don't know, Iterator has already a pretty full method set on what we just said about it. Okay. So let's talk about lending traits, which is my new term I'm trying to get everyone to use. That's the final one I actually like. But the idea is we have all long wanted this idea of a streaming iterator, or what I was calling attached. The idea being that you have an item that is actually borrowing data from the stream or the iterator itself. And we were looking into what it would look like if we tried to add a trait like this. I'm calling it lending because the idea is that the stream lends the data to you, but you don't get to own it. And so the trait might, look, actually I'll make it, the issues are pretty much the same for iterator. So I'm going to do it as iterator just to sidestep some of the like async specific stuff. Basically the trait looks kind of like this. And the idea was, well, if we added this, we probably would want to have some interconversion because every iterator is kind of a lending iterator because, is that right? I think that's right, yes. The idea being that when you use the lending iterator, you can't keep things alive across iterations because you have to kind of give up the data before you call next again. And you can also do that if you own the data. So it's a generalization. However, there's some problems. If we added like, if we add this impl that says, I'm going to implement lending stream for all streams, but then we also have impl like this one that says every box of T is a stream, if T is a stream, and a similar one for lending stream, then you get these ambiguities. Like a box of impl stream can become a lending stream in multiple paths. You can either turn it into a box of impl lending stream and then turn that into a lending stream, or you can turn that into a stream and then turn that into a lending stream. That's kind of a two paths to this diagram thing. And
intersection impulse.
Yeah, maybe, right. So we kind of have this problem. We might need some solutions. I guess intersection impulse is a valid one too.
It's kind of unfortunate that, I mean, let me say this a different way. It feels like it would be nice if we had some kind of higher level generic here where we could say, if you want a borrowed value, I can give you that. And if you want an owned value, I can give you that. And have that be more or less the same trait with a generic return value. That's a challenge, obviously, but that would then mean you have the option of doing either without the ambiguity of it being a different trait.
You actually can't, if we had generic associated types, in some sense, this is the more general version.
That's what I was getting at, yeah.
Because you could have some where clauses that say like where the item, but it's really, they're used somewhat differently. I don't know. It's true that this would be the more general version. It's also true that we don't have all the technology we need, and even when we do, the where clauses, like we need notation that makes it plausible to use in a nice way.
Right, you need a way to spell what the item is that is independent of the generic parameter that it takes, right?
Well, that would not be that hard if you can type inference the x in the 4x in, or even ascribe it. You could say, I want an owned value or I want a reference.
Should be where for tick A, T : item of tick A is static. Where for every lifetime the value is static. Which means it doesn't.
Ways to say it.
They could all not necessarily be the same, right?
That's not what you want to say because
right. It's not. It's because you don't want it to be static necessarily because it could depend on other lifetimes.
Yeah.
So okay, hold on. Let's step back. So
anyway,
yeah, it's a
It
little
would
bit.
probably be a lifetime that came from the impl block instead of the function or something.
I think something like this would be the most realistic way to say it, in terms of like, I don't know what, we don't even have this notation really fully defined, but if we did,
right,
where you're now, just by the way that the scoping works, like this T is kind of outside the scope of this tick underscore, so it can't possibly name that lifetime, so you know it's independent.
I mean, I know this is a straw man like proposal, but the like tick underscore has an existing meaning, right? So you need something new there.
Right. Yeah, leaving apart that part.
Anyway, sorry.
We haven't really said what we'll do with this. But yeah, so there's another question of like, what does this even mean? I don't know. We got enough stuff to work out here that this is partly why I think like we don't really want to block streams on this, on figuring out generic associated types. So I think this is one of those cases that we're going to move forward, but we're going to have to figure this out. I do think, like, it may well be that we wind up, how can I say this? With iterators, at least, we will certainly have two traits, whether they, and with streams too, if we add it, whether we deprecate one in favor of the other because we come up with a great notation, or whether we like use the trait as this is a convenient, they're interoperable automatically and you can use the trait that's most appropriate. I don't know, but we do have to solve this interoperability question. And I think that either intersection impulse, like being able to, which would basically mean you also add a, just for everyone else who's not necessarily doesn't necessarily remember, but having some way to say, okay, these two impls overlap, but we can add an impl that is more specialized just for that overlap. Which I guess would be like lending stream or box of T where T stream. Or maybe some kind of commutativity thing. I don't know.
So the notion here would be that you have the diamond pattern in possible ambiguity, and you are explicitly carving out the bit where they overlap and saying, here's what that bit of the Venn diagram looks like.
Yeah.
It seems like what you're trying to express here is almost a super trait relationship. And like, if you could express that for the purposes of overlap analysis, you might be able to get away with like a default dimple on one leg of the diamond pattern and a non-default dimple on the other. Like blending stream were a super trait of stream, essentially. I mean, that interacts with like Dyn and a lot of other things, but maybe that would.
Yeah, I don't know if that helps. You're right that it is a super trait. And I remember when we were going through specialization, that seems significant sometimes. There are some issues around this intersection impulse, like in part because sometimes the intersections, if I recall, don't really exist. They're like theoretical, but hard to write an impulse for things that can't really exist. The other thought I had was that it would be nice to be able to say that, I think it comes up a lot, that you have, like, you don't really care what route. I don't know what that weird sound is. Is anyone else hearing cool, interesting sounds? But mute a few.
Sounds like a fax machine.
Or Daft Punk.
What I was going to say is, I feel like it happens sometimes that we have impulse where we don't care what order, like in this case, we really care which route we take through these impulses. We don't. And similar to marker traits and so on. I wonder if there's a way to express that, where you basically say the compiler can assemble any landing stream from a stream with some path. But these two impulses are commutative and can be applied in either order.
Can you hear me? Or am I making weird noises?
We can hear you, yeah.
Okay. Yeah, basically what I was suggesting, I don't know if it makes sense, is if you have your like simple lending stream for box T, where T is lending stream, could you make that all default impulse and then have impulse stream for box T where T stream and be non-defaulted? And could you basically say, okay, well now the stream impulse is more specific in every way than the lending stream impulse?
I wanted to quickly interject to ask, did we have like a sort of goal of like, is the primary point of this meeting trying to decide whether we can move forward with the stream RFC as written? Because it seems like we're all sort of on the same page that like we need a solution to this problem, whatever it is, because we already have it for iterator, right?
Yeah, I think that's a good summary of the point. Like, the idea of the RFC is that it's fine that stream will have this problem because iterator does too, and we'll just solve it the same way.
Right. Yeah, that seems like it should be the order of the day here is which of these items are actually blocking us from approving the RFC as written, as opposed to potential future things we might wish to do. One consideration that does seem worth mentioning, if we implement a stream trait in the standard library and we don't provide common combinators for that stream trait, things like map or all the various iterator functions that would be useful in the context of a stream, crates will pop up that provide those helpers atop the standard library trait, and people will start using those, which means that there will be more breakage in the future. No pun intended. So if we know we're going to want those combinators, then it seems like we either want to provide them or we want to make sure that by the time we have this, we also have config accessible, and we explicitly say, if you're going to add combinators, please check if they exist in standard already.
I think that's exactly the conversation we were discussing around futures, and what happens with futures util is that futures util like is that crate that you're talking about that adds all those combinator methods.
Right. But what I'm suggesting is we have a new opportunity because we're moving it into core, which means it's a different type.
But the idea was that futures core would just redirect to the standard library one, or the standard library trait, right? So anyone
And then futures util would still exist, so we'd still have the problem.
Right.
Okay. Then I guess this isn't a new problem. It just seemed worth asking if we could head off that breakage or not, but it sounds like not.
Yeah, there are some other difficulties there in that we're missing language features, specifically async closures, which we need for things like stream filter, where you need to borrow through a closure, and then
or even
some issues. What?
Or even for each, right? You like.
Yeah, or map, or yeah.
Yeah, that's basically the issue, right? Is that if we added them today, they'd be wrong. That's the idea.
And then the other feature that we're missing is async traits, which you need for things like, I believe, either from stream or into stream.
Yeah, from stream, right?
Right. Async trait aside, not to derail things if it's a long answer, but what are we missing to be able to do async closures?
There's design work needed around how they capture things, whether they're captured in the function or just
and syntax and there's a bunch of design work there.
Yeah.
Okay.
It intersects pretty heavily with all the GATs and HRTB stuff.
Got it. Okay.
Yeah, this whole
complicated and not soon. Then it sounds like.
Yes.
I mean, if it could be prioritized, it could be done in medium term, but there's no one to do it, so it's basically the situation.
It is an actually hard problem, not just
Not a let's bike shed the syntax or let's make sure that we're done problem.
Correct.
Yeah.
Okay. Good to know.
Yeah. Anyway, I agree to dial back slightly to what Taylor was saying. That was my goal with this section and this meeting in general, was just this is what we're doing. I want to head off. I want everyone to know what I think the implications are of doing it. But I don't think we have to go too much further into the lending versus not lending precisely.
I have a thing which maybe does actually, just real quickly, I wanted to say, if we're going to wait for a CFG accessible or something fancy like that to do the rest of the combinators, how strongly do y'all feel that next should be there on the initial MVP? Because that seems like it will immediately be a case of this problem, right?
Well, we can move the next method, can't we?
Not at the same time necessarily, but well, so I'm thinking about it. I guess you could force that the new version of futures util depends on the new version of futures core, but you can't force that people don't have a newer version of futures core than they have of futures util.
I also think config accessible is implemented, by the way. Side note.
Sure.
But okay, I was assuming it could be moved atomically. I hadn't considered the.
I mean, you could probably consider it atomic. I don't know who that's going to be a problem for in practice, but technically it would be possible to be using a newer version of futures core than you are of futures util, and that's intentional. So.
Right, so you're saying if futures core redirects to standard libs stream, people, at least today, may still use an older version of futures util, and hence they would still have the next method, basically.
I'd also point out that it's not just the method; the like actual concrete types have to match up, which means that it has to have all the same like debug and whatever the heck else, copy, clone.
You mean for the return type?
Correct. The return type of the next method has to match up.
Well,
If we make sure that the fix for this is as simple as please run cargo update, then it doesn't seem that bad to have this breakage occur.
wait, but are we considering this a non-breaking change to features to do this redirect to std?
I would, yeah. I mean, assuming it's non-breaking.
I mean, I think the only concern I have with that is whether it matters that we're going to break everyone who's not on whatever latest version of Rust adds.
I mean, that's kind of an ongoing, like, long-standing conversation about whether or not requiring a new version of Rust C is a breaking change to your library, right?
Right, but I mean, I was imagining like we're not going to wait very long, or maybe we will.
Do it immediately after release. Yeah, I would say maybe it should wait a couple cycles or something, but I don't like. I'm sort of in the like there's no rush like half why bother camp on the moving to stream trait to std now, but I know other people feel more strongly about it, and I do understand like reasons why we would want something that's more like canonically defined. So I don't see that there's any like particular urgent need to like do the redirect sooner rather than later.
Yeah.
Like it would be nice to like create maybe a cycle for people to move over or something. But
yeah, and I mean I think it was like surveys are showing that people are on latest Rust like pretty like a large majority of people.
I think it was like 3 or 4% at most are on less than most recent stable.
I would definitely expect that people are using a recent Rust more often than they're using a recent version of all their dependencies.
Mm-hmm.
Seems like we should out this transition plan as part of the RFC though, and spell out what it means for.
Yeah, if the method is in the RFC, then yeah, there needs to be some sort of.
I'm not sure how much it talks about it today.
I'd like to be part of those conversations for async std if they happen.
Yeah. In terms
I don't
of
think it's addressed in the RFC as it is right now, so it's definitely something I can add.
Okay. Yeah. It does. Okay. We probably do want to do it as a non-breaking change if we can, right?
That would be vastly preferable. Yes.
Yeah.
Okay. The last topic I had on the list was generator syntax, and I guess 408 syntax kind of ties into that, of not, this is definitely in the camp of like, it's not addressed in the RFC, but a common concern is sort of, are we taking a step that would make generator syntax impossible? Have we coordinated enough? Feel secure, right? And there were a few things that I hadn't fully understood going into the discussion that I found interesting, or I hadn't fully thought about, let's say. Among them, the fact that given that we have the iterator trait and it does not have a pinned self, if we want to have, as I guess I can sketch out, but I think like my assumption at least, is that we would wind up with some syntax such that you can both write an iterator or a stream in a very similar fashion. An interesting implication of this is that iterators, like either there has to be an explicit pinning step or else they can't allow borrows of things on the stack over a yield, right? One or the other.
Yeah, I would have expected that we would need an explicit pinning step or else have a syntax for saying to opting into not being able to borrow things on the stack, right?
Yeah, that's, however, I have a theory that maybe not being able to borrow things in the stack for iterators is something that doesn't bother people. Based on the fact that not being able to borrow like it immediately was apparent with people using features, even with combinators on 0.1, that they needed borrows of things on the stack, right? Because they ended up with these arcs around everything because they couldn't do that.
But you don't
But
think that people would
no
like,
one really had that problem with iterator combinators. So it's worth exploring whether just having them have the static generator semantics for generators, not async generators, for generators, would be.
Well,
I certainly want to be able to loop over, do like a for loop and then yield from the inside of it, which if I'm for looping over something that's borrowed, that like.
Yeah, what's borrowed would have to come into the generator from the outside. So the reference to it would have to be like if you have to slice, it would have to be an argument. It could not be something, a slice owned by that function.
Right,
but if it's coming in from the outside, then it does work because.
right. So I wouldn't necessarily want it to be something. Oh, I see what you're saying. Yeah, assuming what's coming in from the outside might be, for instance, a collection you're implementing an iterator over, then yeah, that might be true. I don't need to borrow from a local in the function, but I do want to borrow from whatever I'm using a generator to not have to hand write an impl iterator for.
Yeah, but so the question is whether you actually need to borrow from locals for like to make this a
Right,
usable feature.
yeah. I was agreeing. I don't think in practice I would want to borrow from locals of the generator very often. I don't mind those being owned. I want to borrow from arguments of the generator typically.
I'm certain I would want to do it at one point, and if there was no way to do it, I would be very upset.
So I think that this is why we need some experimentation, which is why I want to plug propane. I wrote a crate where generators have the static generator semantics. So they're functions that return iterators. You can't borrow cross yields inside of them. And I would it's probably very buggy because I wrote it in like a day, but I would like to get its use to try to experiment and see how often it's a pain. And because there are a range of options, like from not providing the feature to having an explicit syntax for distinguishing between static and non-static generators to always having them have the same be non-static and requiring you to pin them, right? Like there's sort of the spectrum of choice here, and I think what we need is more experience of how much you actually want this functionality and what the right way to handle it is for us.
So wait, is this a crate you recently wrote, Bose?
Yeah, I wrote it a couple weeks ago.
So how does it work? I didn't hear anything about it. So it basically is some kind of generator syntax. Is that the idea?
Yeah, I don't have the hack actually open. I'm just watching on your screen, so I can't type. Instead of trying to find it, I'll just narrate. Yeah, that it's like an attribute you put on like a function, and it changes the function signature to return impl iterator, and it expands your body to be inside of a generator, which you can yield from. And it uses static it has both async and non-async versions, depending on if the function's async or not. And for the non-async version, it uses the static generator feature, which we've always had, which don't allow borrows across yields. And so it does implement unpin, unlike.
So it requires nightly.
Yeah, it's just a thin wrapper over the experimental feature with the set of like options that I think we should consider stabilizing.
I think there's probably a key conversation here, which is around like when we actually want people to use generators, right, rather than writing custom iterators. Since, as we've seen with like async, there's a lot of places where like you kind of need to or currently want to write a manual feature rather than using async await syntax. It's sort of a similar conversation, right?
Yeah, but I would point out also that no one writing custom iterators today is writing self-referential custom iterators, which speaks to how far you can get without that functionality.
So that's cool about the crate. We have 5 minutes left in the meeting. I think we covered all the major topics, which is good. And we found at least one thing to talk about in the RFC, which is the timeline for the transition. I don't know where it is in this document, but is there And I think there was generally agreement that like none of these problems are reasons we can't go forward with the RFC, at least, aren't blocking problems. But basically, if after this we were to open the RFC, I don't know. If you have concerns, you can of course raise them then. But if there are things that you feel we didn't talk about that we should have done, like we should list them out and we can talk about them after the meeting. But, one thing we didn't spend a lot of time on is the motivation for why now. But I mean, I don't want to do that at this moment in the last 5 minutes. But I will say, I mean, the main reason is enabling interoperability and the fact that it's highly requested by, like, pretty much everyone I have spoken to. That's been my main reason.
I don't want to get interoperability if everyone just forwarded a future score. I don't know if anyone detects the salt happening here.
It was like seawater.
Like, I know that Yash could speak for Async Stud, but I know for Tokyo in particular, they wanted, it was a specific thing that they were saying they would really like to have a stable standard library trait that they can reference that will meet their, or else some kind of like multi-year stability guarantee on the part of the futures crate. I don't know, which are not equally good, I don't think. But.
I mean, we're getting consensus on the API so that we can never worry about it again, right? Like that's the advantage of doing this.
Yeah, I'm sold. Yeah. I actually think that's a really good point of that. I'm so glad that I don't have to spend any more time arguing about the futures trait, and it's basically just because it's in stud now and stable.
Yeah, exactly.
Exactly. I'm going to erase this older material since we made doing notes.
Yep.
All right. Well, thanks everybody. And
thank you, everyone. This was really interesting and lots of good information here.
Yep. Ciao.
No.
Ciao.
Right.